In this video we'll go over the Lewis structures of some anions and one cation here in NO+. So the first thing we're going to do is count our valence electrons. Oxygen is happy at 6. We've got 2 of those. The -2 charge here implies that we have gained 2 electrons, so +2. So our goal is to get 14 valence electrons around the O2 - 2 anion, and also realizing it's going to be a -2. So our formal charges must add up to -2. So the way we'll do this here is we'll have an oxygen, there really is no central atom, an oxygen bound to an oxygen atom. And remember again, how will we get a minus formal charge? Okay, forget about the R for a moment, but anything that's bonded to an oxygen in a single bond will have a minus formal charge, right? So 1, 2, 3, 4, 5, 6, 7, oxygen happy at 6, 6 minus 7 is -1. So if I do this situation here, the single bond to the oxygen, and then a single bond to the oxygen. Let's see if I get 14 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And this will have a minus formal charge here, and then this will have a minus formal charge there. -1 and -1 is -2, and that's my -2 in the O2 - 2 molecule. How about C2 - 2? So carbon is tremendously happy at 4. We've got 2 of those, so we have 8. And this E- plus this E- means we've gained 2 electrons. Okay, an electron is a minus charged particle, and we have 2 minus charges that have gained in order for C2 to become -C2. So -2 means we add 2 electrons. So carbon loves 4. How will we get carbon to become 4 while still maintaining that -2 formal charge? This is something that's kind of awkward. I don't think you'll see this a lot in nature, at least not in bio or organic chemistry. But a carbon attached to a carbon, okay, we need to get a -2 formal charge. So how will we do that? 1, and then 2, I'm going to put a triple bond here, 3, and then 4, 5, and then same thing here, 4, 5 for this carbon. So let's count it, make sure we have 10 valence electrons. 1, 2, 3, 4, 5, 6, so these are shared, 7, 8, 9, 10. So I got my 10 valence electrons. Where will we get the -2 here? It's going to come from the formal charge consideration. So let's do our formal charge. 1, 2, 3, 4, 5. Carbon is happy at 4. 4 minus 5 is -1. Okay, so again, carbon loves 4. You won't see this a lot in my estimation. It's just one of those weird molecules, sort of an outlier. Same thing with this molecule here, same thing with this carbon here, excuse me, formal charge, 1, 2, 3, 4, 5. Carbon is happy at 4. 4 minus 5 is -1. Okay, so the -1 formal charge on this carbon plus the -1 formal charge on this carbon, -1 plus -1 is -2, and that's how we get the -2 here. The octet rule is also satisfied. So 1, 2, 3, 4, 5, 6, 7, 8. Octet good for this carbon. 1, 2, 3, 4, 5, 6, 7, 8. The octet is good for that carbon. Finally, let's look at NO+, this cation. So the plus means that we've lost an electron. So nitrogen is happy at 5. Oxygen is happy at 6. The plus sign, as I stated before, means we've lost an electron. So 5 plus 6 minus 1. Our goal is to get 10 valence electrons around the NO+ molecule. So the way we'll do this, the way we'll construct this molecule is we'll have an N, and we'll have a single bond to an oxygen. Now remember, oxygen likes 5, so here's how I can get 5 while still satisfying the octet rule. So 1, 2, 3, 4, 5. Okay, so 1, 2, 3, 4, 5. Nitrogen is happy at 5. 5 minus 5 is 0. So that's really good. But what about this oxygen here? So let's count our total electrons. We need 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So let's do the formal charge for this oxygen. So formal charge for this oxygen here, 1, 2, 3, 4, 5. Oxygen is happy at 6. 6 minus 5 is plus 1. So this is where the plus 1 would be. And this would be a good Lewis structure for NO+. Now let me tell you a bad Lewis structure for this one. A bad Lewis structure would be if you take this pair of electrons, kick it out to nitrogen, and now you're going to get this situation here, okay, where this has 2 lone pairs. Get a double bond, and then you have that lone pair here on the oxygen still staying. So you may think this is valid. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's my 10 valence electrons. The reason why this is not a good Lewis structure is because of formal charge. Another thing is the octet rule, right? 1, 2, 3, 4, 5, 6. You can't get an octet with the oxygen. This rendition, you can get an octet. Also look at the formal charge. So 1, 2, 3, 4. Oxygen happy at 6. 6 minus 4 is plus 2. So a plus 2 formal charge is a lot worse than a plus 1 formal charge. Minimize formal charge is always super important. And let's look at the formal charge here on this nitrogen. 1, 2, 3, 4, 5, and 6. Oxygen happy at 6. Nitrogen happy at 5. So again, let's do the nitrogen formal charge. 1, 2, 3, 4, 5, 6. Nitrogen happy at 5. 5 minus 6 is plus. Here we have a minus 1, excuse me. I apologize for that. So again, 1, 2, 3, 4, 5, 6. Nitrogen happy at 5. 5 minus 6 is minus 1. So 2 minus 1 is your plus 1 here. But this is not a good Lewis structure. The formal charge here, there's a formal charge there, oxygen electronegative atom with a positive formal charge. The net effect is that this is a no-no. This is a much, much, much better structure than this. So we do not move the pair of electrons. The correct structure is this, because once again, this has no formal charge. This has a positive formal charge. Well, we can't get away with that because it's much better to have a positive formal charge than have a positive 2 formal charge on this oxygen and a negative formal charge on that nitrogen.